Okay guys, so let's now move to question 8.4. So the question says, calculate the magnitude of the charge X. So remember, we already know that the magnitude of the charge X is the same as the magnitude of the charge Y because it's identical charges. So even if the question said calculate the magnitude of the charge Y, we would still do the same thing that I'm just going to show you now. So okay, remember we had a point charge X and a point charge Y. We also have a point P there. So in terms of the distance, these were 2 millimeters apart, 3 millimeters apart. So now in this case we're calculating the magnitude of the charge X. So firstly, we can use this formula because we already know the electric net experienced at point P. This point is experiencing a certain magnitude which was given in the statement. So we know we've got 1, 2 charges. That's why I've got a formula as electric net is equals to K, which is a constant charge of X over R squared plus K charge of Y over R squared. So I've got 2 of these because this is experiencing net electric field as a result of these 2 charges. So that's why I've got a formula looking exactly like this one. Okay, on your next step, what you do is just to substitute. We already know the electric net is equals to 5.44 by 10 to the power 6. It's given. So by just substituting this value on the formula, you score a mark. And by the way, you already scored a mark by just writing down the correct formula. So this is equals to K. It's a constant. It's always 9 by 10 to the power 9. It's always given to you as part of the formula sheet. And then you're calculating the charge. So this is the charge of X. So the reason why I made it charge of X, it's so that we bear in mind that when we substitute the distance, is the distance from charge X to this point. So that's why I've got 5 by 10 to the power minus 3. Remember, it's by 10 to the power minus 3 because we had to convert it to meters. So it's actually the distance from there up to there. So it's 2 plus 3. That's why it's 5 by 10 to the 3 to convert it. And don't forget to square. So it's plus into 9 by 10 to the power minus 9 and QY. So that means we'll use the distance from charge Y to that point. So it's given as 3. So it's 3 by 10 to the power minus 3 to convert it to meters. And also remember to square. So your next step, it should be a quick one. So it's more like you are adding this term plus that term. So you just punch all of this on a calculator plus all of this on a calculator, and this is the value that you get. So remember, because you're calculating a charge, then you divide by that number so that it cancels out. And the answer that you get, it should be the magnitude of your charge. And remember, is the magnitude of charge X, which is the same as the magnitude of charge Y. So your last step, you've got your division there. You've just divided the answer by 1.36 by 10 to the power 15 so that it cancels out, and you remain with Q, which is equals to this divided by that. And the answer that you get when you punch on a calculator is this. So this is the answer in coulombs. It's not in a scientific form. So normally what I would do is to count from the comma there and say I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I just stop at that number, which is 4. By 10 to the power, I counted 9 times. So that's why you have minus 9 coulomb. So that's how you get to your final answer, which is 4 by 10 to the power minus 9. With some calculations, your calculator may give you the final answer as in a form of scientific form, but in this case it was in a decimal form, so we had to convert it to a scientific notation. So this is how you write that number in scientific notation. So that's how you simply solve for question 8.4.